The Chronometric Theory of Dimensions by Brian B. Saukier. Time is a fascinating concept that has puzzled scientists and philosophers for centuries. It appears to be moving slightly slower on the Earth's surface compared to any point above it. The theory of relativity states that if two identical twins were to be separated, with one remaining on Earth and the other traveling at high speed in a spaceship to a distant galaxy, the twin on the spaceship would experience time faster. This occurrence causes their aging process to slow down compared to the twin on Earth. Thus, when the twin on the spaceship returns to Earth, they would have aged less than the twin who stayed on Earth. To better understand time, envision a vast circle with a straight line running through the center, stretching from one end to the other. This line is called the diameter of the circle. If you were to walk across the diameter, you would be covering the shortest distance between 2 points, A, B, on the circle, as the diameter provides a direct path. Conversely, if you were to walk around the circumference of the circle from the same points A to B, you would travel a longer distance along a curved path. By walking across the diameter, you would arrive at the other end faster than if you took the circumferential path. Therefore, if you were to race someone walking around the edge of the circle, you would win by taking the diameter instead. In the same way, time can be visualized as such a circle, standing upright. The surface of the Earth travels a longer distance in time by following the circumferential path in time, while someone traveling above the Earth's surface takes a shorter route in time, as they approach the path through the diameter of the time circle. If we were to travel high enough, we could move in a straight path along the perfect diameter of time, making it the quickest way to travel through it. Mathematically, nothing can move faster except using this path at a relative speed if the journey starts and ends on the same points, A to B on the circumference of time itself, and if light takes this route, it is impossible to travel faster than its speed, because that's the shortest route possible. Hence, I project that we can travel at the speed of light, but perhaps not beyond it. Now let's take this concept a step further and imagine that the paths in the circle are made of elastic rubber bands that can be curved and stretched. The presence of massive bodies or strong gravitational pulls can curve and stretch these rubber bands, affecting the path that objects take through time. The heavier the gravitational pull, the more curved and extended the elastic path becomes, making it more difficult for objects to travel faster through time. This means that some lighter objects are simply pulled by the gravitational force of larger bodies, causing their path to stretch and become longer. In essence, the paths that objects take through time are not straight lines, but curved and distorted ones, affected by the presence of massive bodies and their gravitational pulls. This concept provides a new perspective on how gravity affects time. Now, envision the whole galaxies as moving differently in these elastic paths layered within the time circle, all traveling from the same position A to the far end of the circumference on point B. In this regard, some galaxies and their planets travel in time through the circumferential path from A to B, while others take a shorter upper route slightly below the diameter depending on how massive they are and how gravitational pull affects the elasticity of their path. That's why there exist galaxies where time seems to be passing slower or faster than it appears to be on Earth. They're all racing through time using different routes, but their journey originates from the same point ending at one other. As such, I propose that time must be perceived as a genuine dimension of reality, simply disguised as upward movement, not as an illusion. In this regard, time behaves like any other dimension in the sense that it can be curved, warped, and distorted by the presence of matter and energy. This distortion can result in the effects of time dilation, which can cause time to appear to pass differently for observers moving at different speeds or in the presence of massive gravitational fields. Therefore, the chronometric theory of dimensions not only provides a new perspective on the nature of time and dimensions, but also opens up possibilities for new research in the fields of physics and cosmology. Consequently, this theory challenges the traditional belief that the visible world is in 3 dimensions. Instead, up and down are one-dimensional aspects, while forward or backward movement is an attribute of another dimension, which implies that we live in a 2-dimensional world. The notion believed by physicists, which stipulates that there exists 3 dimensions in the physical universe, is founded on error and is impossible to comprehend. What we perceive as a three-dimensional universe is merely a misrepresented 2D model of it. Hence, when we walk on the surface of the Earth, we are simply moving on one dimension in different directions, and claiming that turning a 90-degree angle on this surface of the Earth is walking in 2 dimensions is akin to saying that going up in a slanting direction, that is 45 degrees from the surface of the Earth, is walking in a 4th dimension. Using the same logic, such an idea leads to an infinite number of dimensions, since any slight increase-decrease in angle, whether walking vertically or horizontally, could mean that we are moving in a new dimension altogether. The problem is that our current understanding of dimensions is intertwined with directions. Another mistake that physicists make is confusing sides with dimensions. The inside and outside of the same object cannot be considered as dimensions. The mere presence of an inside and an outside in a bottle does not imply that the inside constitutes a separate dimension from the outside. In fact, both the inside and the outside are merely 2 aspects of the same entity. A similar argument can be made for the 2 sides of a coin. The head and tail of a coin do not necessarily represent 2 distinct dimensions, as this interpretation could lead to an infinite number of dimensions for any given object. To provide an illustration of this concept, let us consider the angle formed by the corner of a living room. Physicists and mathematicians assert that the corner, where 2 surfaces meet at a 90-degree angle, represents 3 dimensions. However, I must respectfully disagree. The fact that 2 walls join to form an angle on a surface does not automatically make that surface 2-dimensional. Rather, it remains a flat surface with 2 perpendicular walls standing upright facing different angles. In other words, the corner of a room represents only 2 directions of the same dimension, rather than constituting an additional dimension. By avoiding these common mistakes, we are left with 2 dimensions, surface and upwards, or time. Any dimensions that come after that can be called the 2nd, 3rd, and 4th dimensions. It is possible that we may encounter the 3rd dimension, although I am skeptical that it can be detected even with the most advanced microscope. Rather, any microscope would merely reveal the internal or external structure of the universe's tiniest building blocks. My theory is that the 3rd dimension is the realm of the mind or thought, which is beyond the reach of our eyes or the confines of paper. It can only be perceived by our brains, and we access it when we engage in thinking. While we can traverse upward, downward, diagonal, forward, backward, or diagonal dimensions, we are unable to journey through thought, rendering the 3rd dimension an enigma to us. In essence, the 3rd dimension is a concept that exists beyond the physical realm, and it is only through the power of our minds that we can begin to comprehend it. While my theory may be difficult to comprehend, it opens up new possibilities for exploring the mysteries of the universe. Created and simplified by Brian Saukir Banda,